Okay, cool. Well, we'll just stick with this schedule then until I hear differently from you.
Okay. So
And
I sent you, what?
I got them right here.
This is a quiz that we took, and I didn't do too well on it. And the ones that don't have, looks like a purple check mark, I did wrong.
Okay.
So we'll just go over the ones I did wrong.
So let's look at number 3.
Okay.
When you are simplifying square roots, you're looking for factors of 32 where one of them is a perfect square number.
Mm-hmm.
Okay, well, here's your perfect square numbers. When you do simplification of cube roots, you're not looking for perfect square numbers, you're looking for perfect cube numbers.
Right.
That's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. So whenever you're trying to simplify that, you're looking for a factor of 32 that is one of these perfect cube numbers. Well,
Okay.
8.
8. Okay.
Okay. So I can rewrite this problem as the cube root of 8 times the cube root of 4.
Okay.
Okay. In fact, let me erase the square root stuff because it's not applicable when you're doing cube roots. And same if you're doing fourth roots. I would want numbers that were perfect powers of 4. But in this particular case, the reason this is helpful is because I can pull an integer out of that. The cube root of 8 is what?
2.
So it's 2 cube root 4.
Okay.
That would be the answer. Now I know on this problem they didn't say give them the answer, just tell them why it's not simplified. And
right.
her reason there is that one of the radical has a factor that is a perfect cube number.
Okay.
Okay. Did you lose a point on number 4?
Yeah.
Yes, I see what happened here. Again, if we are doing the square root of 48, we want to turn that into one of the factors needs to be a perfect square. Well,
right.
You did 24 and 2, neither of which is a perfect square.
Right.
Nor is 6 and 8. That would also not work.
Right.
So we're looking for a factor of 48 that's one of those perfect square numbers. Well, 16 is 3 times 16 is 48. But that's a hard one to find. And of course, if you did it the most efficient way, it would be 16 times 3, which would be 4 square root of 3. But like I said, it's not always so easy to find factors that are bigger numbers. So most of the time, all of these are going to be, you can divide them by 4. Okay, so if I did that, it's going to get you to the right answer, or it may be a little longer, because now that becomes 2 root 12, but root 12 is also can be divided by 4. And now I have 2 times 2, root 3, which gets me to that final correct answer.
Gotcha.
So it's not particularly important that you find the greatest factor. It's just helpful. In other words, I'd have been better off, rather than splitting that into that, I would have been a lot better off splitting it into root 16 times root 3, because that gets me the answer in basically one step.
Right.
Whereas the way I did it by constantly using 4, notice that 4 times 4 is 16. So a lot of times when something is divisible by 4, you should also check and see if it's divisible by 16, just because it might save you some.
Okay. That makes sense.
All right. Let me open the second page here. That was all there was on that first page, correct?
And I forgot to ask this, and I should have asked you earlier. Could we, by any chance, just do like a 30-minute session today?
Sure. No, that's
okay.
Yeah.
Does that work for you? Because if not, I'm okay.
No, that works for me for sure.
Okay.
Okay, scientific notation. The key on scientific notation is that you have a number between 1 and 10 times 10 to some power.
Right.
So this number that they gave us, 45 times 10 to the minus 12th, is not in scientific notation because 45 is not between 1 and 10. So the very first thing I have to do is figure out what to do here. Well, if I divide that by 10, I can make it 4.5, right? Well, if I divided that by 10, well, I have to make that power 1 more. Let me start with, and this is the way you can always figure this out. 10 equals 10 to the 1, right? So if I wanted to change the 10 to a 1, I would have to, well, hold on, let me do this differently, excuse me. Right? So if I wanted to write this in scientific notation, in other words, right now I have the number 100. If I want to change it to 1, it's 1 times 10 to the second. It's actually currently 1 times 10 to the 0. Anything to the 0 is 1. So let's look at this number right here. 100 is actually 100 times 10 to the 0 power. So if I want to change this by 2 decimal places to the left, in other words, if I want to move my decimal point from there to there, then I have to add 2 to this. So 100 times 10 to the 0 becomes 1 times 10 squared. Let's take the number 12 times 10 to the 1. Well, what is that number?
Wouldn't that be brain work? Just 1200?
12 times 10. In other words, 10 to the 1 is 10.
Right.
So 10 times 12 is just 120.
Oh, okay, yeah. That makes sense.
So now, the key is, in other words, this gets tricky to memorize. Which way you move the decimal point and whether you move it left or right, do you add or subtract from the exponent?
Right.
Well, I know that number is 120. So if I want to change this to 1.2, in other words, if I want to put it in true scientific notation where this number is between 1 and 10 and not greater than 10, like 12 is, I can do that. And here's the thing. I know that 1.2 times 100 would be 120. So therefore, I have to add 1. That number is also 120. In other words, both of these numbers are the same number. And by working with a small number like this, one where you can figure out what the actual number is, it gives you a method of which way, when you move the decimal point, what do you do to the exponent on the 10? In the same way that if I had 0.12, what should that be? If I'm trying to get that equal to 120, well, what's that? What do I need in the way of an exponent?
It'd be 10 to the third.
Yeah. In other words, that's also that same number. So now I can see that as I'm moving my decimal to the left, every single spot, I have to add 1 to the exponent.
Right.
So now let's look at this problem, which is relatively simple because we only have to move it 1 spot. In other words, I've got to change the 45 to a 4.5. Well, where's the decimal point? It's right there right now. So to change it to 4.5, I've moved it 1 spot, which means I have to add 1. What's my new exponent?
That would be negative 11.
Correct. That's the same number as that. And that's the important thing, is that you never change the number. And I noticed you wrote the number out here, and that's all fine and good, but now notice that if I knew that was the number, how many spots do I have to? I'm going to have to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay.
So when I'm moving the decimal point to the right, I have to subtract from the exponent.
Okay.
If I were to write that number, it would be times 10 to the 0. If I wrote this number the way you've written it, only I was attempting to put it into scientific notation of some kind, it would be times 10 to the 0, because that's the number 1. And now, if I'm going to move my decimal point 11 places, I've got to subtract 11 from that 0, so I end up with 10 to the minus 11. But that's certainly doing it the hard way. In other words, this is doing it the hard way. It's easier to start with that, move the decimal point 1 to the left, and add 1 to the exponent. And that's the only thing you have to memorize with scientific notation. You have to know that this number has to be between 1 and not 10. It cannot be 10. 9.999. If I had a 10, I would change it to 1.0. Say if I had 10 times 10 to the third, well, that would become 1.0 times 10 to the fourth.
Okay, that makes so much more sense.
That would be scientific notation, because this number is between greater than or equal to 1, and it's less than 10. That's the rule.
Okay. That makes so much more sense. I struggled even with that in high school. Now it finally makes sense.
Let me give you a test. Give me that number in scientific notation. Now, I'm going to help you out by making this number read like this.
Okay.
And sometimes that's helpful to do. In other words, if they just give you a regular number without the times 10, you can always add that. That's the number 1.
Right.
So in scientific notation, what would this be?
That would be 3.5 times 10 to the second.
Correct.
Yeah.
Because the decimal point had to go 1, 2 spots.
Right.
So decimal point moving left, add. Decimal point moving right, subtract.
Okay.
Ooh, good answer. Good answer. It's not really, well, this is actually called an indeterminate.
Yeah, he said either indeterminate or undefined was fine. He went over that one in
But
class.
here's the amazing thing that I don't get, and I've never gotten it, and I would love somebody to explain it to me. And that's that if I take a variable and raise it to the x power or to the 0 power, that's always equal to 1.
Right.
Even if x is 0. So 0 to the 0 power, I'll bet you more than half his students answered that.
Yeah, probably.
And I'm still not clear why it's not automatically 1. You're correct. In my calculus book, it says that 0 to the 0th power is undetermined or indeterminate. In other words, it's not always the same. Sometimes it's 1, sometimes it's 0, sometimes it's infinity. That's what indeterminate means. It's a lot like if I said, what is infinity divided by infinity? Wouldn't know. That's not 1.
Right.
Okay? Also, what if I have 0 times infinity? Don't know what that is. What is 0 divided by 0? Don't know what that is. All of those are indeterminates. The one that just puzzles me is this one, because this one's always 1. I don't get why it's indeterminate, but I'll leave that to other people. I won't try to solve that problem with you today.
All right.
Okay.
So on this one, I erased it a bunch, but like what I started
What
doing.
you did. No, I like what you did here. This is perfect. Way to start. Can you see circling?
Yeah.
In other words, the first goal is to get rid of the parentheses. So you multiply that exponent by each of these exponents. What you didn't do was multiply it or apply it to the 3.
You're right. That's what I didn't do.
What is 3 to the minus 2 equal to?
9.
1/9.
1/9.
In other words, it's equal to 1 over 3 to the positive 2, which is 1/9. So this 6 really needed to be a 9 in the denominator.
Okay.
Because it needs to go to the denominator because of that negative exponent. In the same way that the y to the 10th turns in, y to the 5th turns into y to the minus 10th, which turns into y to the 10th in the denominator.
Right.
So if we go through this thing, let's do the numerator first. Okay, well, when I apply that to the 3, I get 1/9. That's in the numerator. And then I get x to the positive 8. And then I get y to the minus 10. And now we'll leave it like that.
Okay.
X to the minus 8. Now, it is kind of important in math that you understand that if I move that 9 to the denominator, it's the same thing. In other words, the way I have it written right now is confusing, so let's put that 9 down here. Now we're perfect. Okay. Now, what are the net x's?
Isn't it just x? No.
If you have the same base and you're dividing, what do you do with the exponents?
You subtract them.
Okay, what is 8 minus a minus 8?
8 minus, that is 16.
That's the numerator, x to the 16th. That takes care of that, takes care of that.
Okay.
The y to the minus 10, we're going to write down here.
Mm-hmm.
Because they said give answers with no negative exponents. That's almost a double negative if ever I've seen one.
Right.
You know what I'm saying?
Yeah.
And the 9 goes down there. I mean, that's probably not a double negative technically in English class, but I think it would have been better written, give answers without negative exponents.
Right.
I'm not sure that isn't a double negative. It might be.
Yeah. See, now that makes sense. I see where I messed up.
This is just a one step at a time process. In other words, no matter how complicated this is, no matter how many variables they give you, you can always just take the exponent and apply it to each thing inside the parentheses.
Right.
It's all you have to do there. Okay.
Yeah. I just I remember him saying the class before we took this test, like make sure you like apply the exponent to all that's in the parentheses.
Yes.
And I always forgot the
that's a hard
like the number in front of like x.
There's a big difference between this and this.
Yeah.
That's equal to 3x squared. This is equal to 9x squared.
Right.
So
that's like what I just forgot. And like as soon as he went over
negative, it makes it even more difficult to think about.
Yeah. And as soon as he mentioned it in class, like I felt so dumb. I was like, I knew that, but I forgot.
Yeah, this is pretty much stuff. It looks like you have some new stuff. This indeterminate thing is interesting.
Mm-hmm.
You didn't have that in high school.
No.
But most everything else I see here, in fact, you probably have to go back to 7th or 8th grade for scientific notation.
I remember doing that in like 7th grade, and it didn't make any sense to me then.
I don't get that from any high school students. I only run into scientific notation problems when I'm working with a 7th or 8th grader, or in your case. In other words, the higher up you go in math, the more scientific notation becomes important because you're dealing with monstrous numbers. When I'm dealing with the distance to Alpha Centaurus, I got to use scientific notation, otherwise I'm going to be writing zeros all day long. And in fact, this is the whole reason for scientific notation, so that you don't have to write it like this.
Right. And then the standard notation for that one would be the 4.5 times x to the negative 11, right?
That's the scientific notation. Standard form, I didn't realize that they wanted it in both.
Yeah, I just caught that.
That's standard form right there.
Oh, okay.
So you wrote it in standard form. I don't know why you lost 1 point. You should have only lost a half a point.
Huh. That's true.
Or else, maybe I'm wrong. That might not be two different forms. That might be one form only. And based on her answer, 4.5 times 10 to the minus 11th, that's the only answer she gives. This she's calling decimal form. So this must be decimal form. I guess that's not standard form. I'm not sure what standard. I think scientific notation standard form means one thing only. It means you put it in this kind of a form, and this number has to be between 1 and 10.
Okay.
That's what scientific notation standard form has to mean.
Okay. That makes sense, I guess.
Yeah, otherwise, she's calling that's not standard form for sure. And I don't know, I might be wrong. Standard form may be a third thing entirely, but I don't know what it is if it is a third thing. But I don't
I
think
could
it
not
is
tell you.
because, well, she would have written it on here. In other words, if
Yeah.
there was a standard form, she would have put it down here. Now, maybe standard form is this form right here. I don't know. But I don't think so. I think scientific notation standard form means this.
Gotcha. Okay.
All right.
Well, that helps. All right.
So
I can always ask her later about it.
Okay. So, you have any other questions, Taryn, or are you good to go?
I think I'm good to go. I feel pretty confident about this stuff now, just realizing my little mistakes.
Okay. If you do decide that you want to go to a third hour during any given week, you can always just call me or email me. I've got this spot, this 2 o'clock spot, open almost every day, so it's not likely to go away. But you can also go onto my website and schedule without talking to me. In other words, it'll show you all my availability and let you schedule the session.
Oh, cool.
Okay. What else was I thinking here? Oh, I was going to say you're lucky you're in California today. We got a foot and a half of snow here.
Yeah, I've been seeing everyone's posts and stuff on Facebook, how it's been like a second snow day or something like that.
It's the biggest snow. Yeah, that's right. They canceled all the schools, and it's the biggest snow of the year. I haven't had to do this much shoveling. So,
That is crazy.
yeah.
Oh, jeez. And I was complaining because it was windy and cold last night.
Oh, that's right. You're where the golf tournament was just played, and it was very windy and rainy and cold. But so you guys are getting the effects of El Nino. So you're experiencing California in the rain probably for the first time of anybody that's lived there for 6 or 7 years.
Basically, yeah.
Yeah.
They said February is going to be pretty bad, so
Yeah, but I'm
we'll
sure
see.
it's probably a fine line between too much rain and too little. But too little rain, that not good. That has to change. So
Yeah, that's for sure.
good for California, I think, that this El Nino is going to do what it's going to do this year.
Right.
All right, Taryn, I will talk to you on Thursday.
All right. Thank you so much.
All right, bye-bye.